So far we have seen linear homogeneous equations with constant coefficients. This time linear non-homogeneous recurrent relations with constant coefficients. How it looks like? It will be like linear and homogeneous, same. The only difference is you will get f of n extra, that's it. So an equal to c1 into an minus 1 plus c2 an minus 2 so on ck n minus k plus f of n is called. So this is c automatically linear and it is not homogeneous because so you have recurrence terms followed by some function. If you don't have this f of n, if f of n is 0, then this equation will become homogeneous. If you have f of n, then that will become non-homogeneous. Whenever you have non-homogeneous equation like this, which is linear, then still we have solution. That solution will have this kind of formula. The structure is, so you will have first particular solution. So we have to compute it. I will tell you how to find out. We denote it by an whole power p, just symbolically. So here in the braces, whenever I write an, it is solution for the recurrence relation an. So this is a solution, especially p corresponds to particular solution. So I say that we have to find out particular solution. Second one, homogeneous solution. So you know how to find out homogeneous solution. What is that, sir? So for linear homogeneous recurrent relations, you have found the solutions, right? They are called homogeneous solutions. So for this problem, we have to find out that homogeneous solutions, particular solutions, and we have to add them finally. Sir, how to find out homogeneous solution? I will tell you. How to find out particular solution? I am going to tell you. First of all, so we'll see how to find out particular solution. Let's come to this formula. This is the solution finally. So f of n is dash, f of n is in this form. If you are f of n in this form, that means it's polynomial, you see. So generally we write polynomial in this way. What is that? Some constant into, that means some coefficient into n power t plus some coefficient into n power t minus 1 in that way, plus finally some coefficient into some s power n. If you have this kind of function, then only we can find out the solution. We have a solution for that. Understand? So we have solutions only for linear non-homogeneous recurrent relations, especially where f of n is in this form. What is that? Polynomial into s power n. Okay, we'll see one example of that f of n. What if your f of n is n square plus 5n plus 9 into 3 power n. Okay, so this is f of n. So here let me identify everything. So what is bt here? Because your polynomial, if you see, of order t, so here order 2, then I can say that your polynomial is b2 into n power 2 plus b1 into n power 1 plus b0. See, that is what the meaning of this entire structure into s power n. Here s is nothing but 3, right? S power n. So let me identify what is b2. So b2 is nothing but 1 into n, right? That's why 1. So b1 into n, 5 into n. b1 is 5. So b0 is here 9 and s is here 3. So this is about f of n. Finally, you have some linear non-homogeneous recurrent relation with some f of n in the form of polynomial into some constant power n. When you have such f of n, then we have a solution. Sir, what is that solution? Particular solution. Okay. So you know that we have to find out particular solution, homogeneous solution. So I am going to teach you first how to find out particular solution. So the particular solution depends on two cases, case 1, case 2. In case number 1, your this s which we are talking about now, that s is root of your characteristic equation. Sir, what is characteristic equation? So this is, if you see this part, is it not, homogeneous part? For this one, we have to find out characteristic equation. We know how to find out. We will find out. Okay. That characteristic equation will have roots, yes or no? Then, accidentally, if that s, this s, which is part of your function, okay, that s is root of this characteristic equation, then particular solution is in one way. If your s is not root of this characteristic equation, then particular solution is in another way. Okay. So let's take case number 1. Let's read it. If s, which is this one, is not a root of the characteristic equation, then the particular solution is in this form. What is that? pt. Sir, what is pt? Some constant, okay, which is coefficient of n power t. Some constant into n power t plus some constant into n power t minus 1 plus so on some constant into s power n is the solution. Sir, what is pt, pt minus 1? They are all constants. We have to find out their values, like which we did when we were doing, homogeneous equation solutions. Alpha 1 0, alpha 1 1, alpha 1 2. What were they? In the same way, pt, pt minus 1, everything is constants. We have to find out their values. Okay. Now, case number 2. In case number 2, if S is root of the characteristic equation, then what is the answer? The particular solution of your problem is Pt into n power t. Sir, same? Yes. Pt minus 1 into n power t minus 1. Same, sir, up to P naught into n to the power of m into s power n. The only factor is n power m is different from this one. So this is about, particular solution. Once you get particular solution, now let me give the summary. So answer for our problem is, so finally what you want? You want the solution for this recurrence relation. For that answer is, we have to find out the particular solution for your equation plus homogeneous solution. I will tell you what is homogeneous solution and you know what is particular solution. Just now you have studied it. Okay. Now I will tell you how to find out particular solution clearly with an example. Then only you will understand it. Let's take one example and find out the particular solution. Now consider this example. An equal to 6 an minus 1 minus 8 an minus 2 plus 9. So we have to find out homogeneous solution and particular solution. First we see how to find out particular solution. For that first we need characteristic equation, because the solution, particular solution also depends on roots of the characteristic equation. That's why characteristic equation is important. So you know how to calculate characteristic equation, r power k, where order is 2, correct? R square minus this 6 into r plus, because it is minus 8, it will become plus 8 into r power 0, 8 equal to 0. Then if you simplify it, you get r minus 4 into r minus 2, correct? Minus 4 minus 2 minus 6, minus 4 into minus 2 plus 8, so you know how to find out the roots for equation. So once it is over, then r equal to 4 or r equal to 2. So these are the roots, right? Now come to first of all, our non-homogeneous equation 9 here, right? So this is what f of n. So what is the form of your f of n according to the definition? It is bt into n power t plus bt minus 1 n power t minus 1 so on up to b naught into s power n. Let me write your 9 into b naught into, this form. So that is nothing but here it will be b naught into s power n. Sir, we don't have s power n, then we can write 1 power n. Try to understand. So your equation is in this form, right? F of n, 9, right? Just 9 can be written as 9 into 1 power n. So where 9 can be treated as b naught. So now your equation is in dash form, b naught into 1 power n. See here, b naught into 1 power n, where b naught is 9. For that, so what is the solution, particular solution? If you read, there are two cases. Case number 1, if s is not a root of the characteristic equation. What is s here? 1, correct? So 1 is it the root of the characteristic equation? No. Then case number 2, if s is not a root of the characteristic equation, it will be case number 1. Then particular solution directly pt into n power t plus so on. So these are all not significant for us. Why? Our function doesn't have n power t term. If your function has n power t, then we should write pt into n power t into your solution. So directly we have in our function, we have only b naught, correct? Then we should take only p naught. So solution is p naught into, okay. So I am writing particular solution into s power n. What is s here? 1 power n. 1 power n is 1. So finally p naught is the answer. This is a particular solution. Sir, but what is p naught value? I will tell you. How to find out p naught value? I will tell you. So take the particular solution and substitute in your recurrence relation. Then you get, p naught value. Let me substitute. So an equal to, I am writing it again, an equal to 6 into an minus 1 minus 8 into an minus 2 plus 9. In that I am substituting particular solution. Particular solution actually satisfies this equation. Okay, so let's substitute. So an is nothing but p naught. P naught equal to 6 into an minus 1. If an is constant p naught, what is an minus 1? An minus 1 also will become p naught because p naught is a constant. So it is not depending on variable n. Then if an is p naught, an minus 1 also p naught, right? So that's why it will be 6 into p naught minus 8 into an minus 2 also is the same way p naught plus 9. Let's simplify it. P naught equal to 6 p naught minus 8 p naught minus 2 p naught plus 9. So minus 2 p naught plus p naught will be 3 p naught, correct? If minus 2 p naught goes there, then equal to 9, then p naught equal to 3. I got the value of p naught. In that way, we can find out always this kind of constants p naught, p1, everything by substituting your, that particular solution into recurrence relation. That's it. So once you get p naught equal to 3, then what to do? I will tell you. So our final answer, solution for recurrence relation, always you remember particular solution of your recurrence relation plus homogeneous solution. Just now we got particular solution which is just 3 plus homogeneous solution. What is homogeneous solution, sir? Ignore this 9 and take this homogeneous equation and find out the solution for it, then that will become homogeneous solution. How to find out homogeneous solution? How to find out the solution for homogeneous recurrence relation? That will be using the characteristic equation, correct? Since characteristic equation has roots 4 comma, did you remember 2, correct? So whenever you have roots 4 comma 2, please recall homogeneous recurrence solutions. So they are nothing but, did you remember, it will be alpha 1 0 into first root, let's say 4, this is second root, r1 r2 r1 power n, 4 power n, plus alpha 2 0, this is constant for this one, second root, into 2 power n. Okay, so this is the answer which is homogeneous solution. Now final answer is 3 plus alpha 1 0 into 4 power n plus alpha 2 0 into 2 power n. Okay, so this is the final answer. Sir, but how to find out alpha 1 0 and alpha 2 0, sir? I will tell you. Simply, because we know that a naught equal to 10, this is an, right? So substitute a naught, n value 0. Then what happens? It will become 3 plus alpha 1 0 into 4 power 0 plus alpha 2 0 into 2 power 0. Then you get one equation. What is a naught value? 10. 10 equal to 3 plus alpha 1 0 into 4 power 0, 1. Alpha 1 0 into 1 plus alpha 2 0 into 1. So finally it will become alpha 1 0 plus alpha 2 0 equal to 7. Remember equation number 1. Let's substitute n value 1. If n value 1, then what happens? A1 equal to 3 plus alpha 1 0 into 4 power 1 plus alpha 2 0 into 2 power 1. So it would become, what is A1? 25. 25 equal to 3 plus alpha 1 0 into 4 plus alpha 2 0 into 2 alpha 2 0. Okay. So if you simplify it, it will become alpha 1 0 into 4 alpha 1 0 plus 2 into alpha 2 0, that would become 25 minus 3, 22. So if you simplify these two equations, you know how to eliminate variables. Using that we can find out alpha 1 0, alpha 2 0. Okay, so let me, how to do that? Simply multiply first equation with 4. Then what happens? 4 alpha 1 0 plus 4 alpha 2 0 will be 28. Then subtract. Then what happens? This will be cancelled. You get 4 alpha 2 0 minus 2 alpha 2 0 is what? 2 into alpha 2 0, which is nothing but 28 minus 22, which is 6. Then alpha 2 0 equal to 6 by 2, which is nothing but 3. Once you get alpha 1 0, we can alpha 2 0, we can find out alpha 1 0. How to find out alpha 1 0? See the first equation. So alpha 1 0 plus alpha 2 0 was 7. Did you remember? Alpha 1 0 plus alpha 2 0 is 7. So alpha 2 0 is 3. Then alpha 1 0 supposed to be 4. Correct? 4 plus 3 7. In that way we can find out alpha 1 0, alpha 2 0. After finding them, substitute them back. So final answer is 3 plus alpha 1 0, which is 4 into 4 power n, plus alpha 2 0, which is nothing but what? Just now we got 3 into 2 power n. That's it. This is the final solution. In that way we can find out solutions for non-homogeneous recurrent relations. For that, find out the particular solution followed by find out the homogeneous solution. That's it. Let's see one more example. Problem is an equal to 6 an minus 1 minus 8 into an minus 2 up to here same plus n into 4 power n. So we are trying all different cases. So here f of n is in dash form n into 4 power n. We know that now it is non-homogeneous equation, right? So let's map this n into 4 power n to this one. It is like b1 into n, correct, plus b naught. Of course b naught is 0, we know that. B1 is 1, okay. So b1 into n plus b naught into s power n, correct. This is the form. So whenever your function matches with this form, then the solution is either this one or this one, depends on your s. What is s in your function? S value 4 here, correct, 4 power n, right. So let's simply read these cases. Case number 1, if s is not a root of the characteristic equation, so let's check it. So we know that for this problem, so what is characteristic equation? It will be r power 2 minus, because same previous problem, then it will be r square minus 6r plus 8 equal to 0. Then we know that it is r minus 4 into r minus 2 equal to 0. Then r equal to 4 or r equal to 2. Yes, so one of the root is 4. That means your s is one of the root. If your s is one of the root, then case number 1 will not work, because case number 1, when f is not a characteristic equation. Then we should go to case number 2. In case number 2, if s is root of the characteristic equation and m is multiplicity of the root. So how many times 4 is repeated in these roots? Only one time, correct. So 4 is only repeated one time. If you have r minus 4 whole square, we say 4 is repeated 2 times. That's why here only one time it is repeated. Then the formula is, particular solution is pt into n power t. For bt into n power t, we should write pt into n power t. So we have b1 into n. For that we should write p1 into n. Okay. So this p1 we have to compute, plus p naught. In the place of b naught, we should write p naught. Don't say that, sir, our b naught is 0, then should I take? Yes, you should take it. Okay. So if b naught is 0 or 5 or anything, we should have a corresponding term. Okay. So p1 into n plus p naught. That is the form. So and remember, sir, what if my equation is n square plus 5n plus 6 into 4 power n? What would be the corresponding this particular solution? Simple. First of all, what is your equation form? It would be like this, correct? b2 into n square plus b1 into n, see, plus b naught. Further solution will be p2 into n square plus p1 into n plus p naught. Okay. In that way we can always find out the corresponding particular solution. So here p1 into n plus p naught, see, completely into, because of this is extra. If s is not root, then we don't get n power m, but here we get n power m. N power, sir, what is m? Multiplicity of that root in the characteristic equation. So since it is only one time repeated, it will be n power 1 into s power n. Sir, what is s? Same s. So of your, in 4 power n, s is 4. So 4 power dash n. So directly copy 4 power n. So this will be the particular solution. Sir, but how to find out p1 value, p0 value? So it will be complex, but I will tell you how to find out. Simply, already I told you, particular solution satisfies your recurrence relation. Remember it. Then if you substitute this particular solution in this recurrence relation, you can get p1 value, p0 value. I will show you how to find out that. Okay. So this is your particular solution. Remember, final solution is not this one. Final solution is particular solution plus homogeneous solution. We know how to find out homogeneous solution, but first we find out particular solution. So my goal is now finding p1 value, p0 value. For that, what I do is I substitute this equation into recurrence relation. Let me do it. Let's blindly substitute into recurrence relation. What is your recurrence relation? An equal to 6 into an minus 1 minus 8 into an minus 2 plus n into 4 power n. So blindly follow the procedures what I am telling, because it's a complex topic. So all these things, like example, particular solution satisfies this recurrence relation is just result. So I'm just using the results. Okay, so that's why, because there is a proof for everything, but the proofs are very difficult to understand for you and inappropriate for gate. That's why, so we only focus on the results, right? So there are a lot of results. Example, particular solution form is this one, otherwise what is characteristic equation, everything is result. Remember them, just follow the procedure how I am calculating, that is enough for us. Okay, right? So remember, every particular solution according to the theorem, it automatically satisfies your recurrence relation. So let me substitute. So what is an? In the place of an, I write p1n plus p0 into n into 4 power n, which is equal to, I am substituting 6 into, otherwise here you see 6 into an minus 1. In the place of an minus 1, write the particular solution of n minus 1 term. This is for an, correct? This is the particular solution for an. What is the particular solution for an minus 1? Tell me. I write here first. Particular solution for an minus 1 is, see, p1 into n minus 1, because in the place of n you should write n minus 1. In the place of n it will become n minus 1 plus p naught, right, into n into 4 power n is for particular solution of an. Then for particular solution of n minus 1 it would become n minus 1 into 4 power n minus 1. Let me copy that. Okay, I am copying it. So p1 into n minus 1 plus p naught, right, this entire thing, let me put brace, this overall thing is multiplied with n minus 1 into 4 power n minus 1. Fine. So this is about particular solution of an minus 1 minus 8 into an minus 2. What is an minus 2? Particular solution of an minus 2, same thing, let me write it. Particular solution of an minus 2 equal to p1 into n minus 2 plus p naught, correct, brace, into n into 4 power n will become n minus 2 into 4 power n minus 2, because our term here is n minus 2. So let's substitute it. So I'm writing it here, p1 into n minus 2 into plus p naught, this overall, into n minus 2 into 4 power n minus 2. Okay, so this is about an minus 2's particular solution, plus n into 4 power n, copy it as it is, because we are writing particular solution for an, correct? In an we have to write an minus 1's particular solution into 6 minus 8 into particular solution of an minus 2 plus n into 4 power n, n into 4 power n. So once this step is done, what we did, we have substituted particular solution into your recurrence relation. Once it is done, then we have to identify p naught value, p1 value. How to do that? Simply substitute n equal to 0, you get one equation, and after that you substitute n equal to 1, you get one equation between p naught and p1. These two equations are enough to simplify p naught value, p1 value. Let's substitute n value 0 so that you will understand. So if n equal to 0, then what happens to this equation? So it will be p1 into 0, 0 plus p naught, so p naught into, so 0, 0 into anything is 0, then this will become 0, right, overall. 0 equal to 6 into, let's see, so here minus 1, right, n is 0, 0 minus 1 minus 1, minus 1 into p1 minus p1 plus p naught, overall brace, into n minus 1, which is minus 1 into 4 power 0 minus 1. So I am substituting n is 0, 4 power minus 1. Okay, so minus 8 into p1 into 0 minus 2 minus 2 plus p naught, whole brace, into n minus 2, which is 0 minus 2 minus 2 into 4 power 0 minus 2, 4 power minus 2, whole brace, plus 0 into 4 power n, which is nothing but 0. If you simplify it, you get 0 equal to 6 into, so here see, p naught plus p naught minus p1 is nothing but p naught minus p1, correct? P naught minus p1 into minus 1 if I do, then the positions will be changed, correct? You get p1 minus p naught, correct? So finally p naught minus p1 into minus 1 is p1 minus p naught into 4 power minus 1, which is nothing but by 4, correct? I can do by 4. So minus 8 into this one. If you see this one, it is p naught minus 2p1. into minus 2, then their positions again will be changed. If you have P naught minus 2P1, if I multiply with minus 1, what happens? It will become 2P1 minus P naught. But you are multiplying with again with 2. Don't do that, because we have here 4 power minus 2. 4 power minus 2 is nothing but 1 by 4 square, which is 1 by 16, right? So 1 by 16 if you have here, and if I multiply with 2, then this would become 1 by 8, correct? So 1 by 8, let's write it. And so I write one more time, P naught minus 2P1, okay, into minus 1, and 4 power minus 2 is simplified by this 2, correct? You got by 8. So this 8 will be cancelled. Now this minus and this minus will become plus. So this is all simplification. Of course you can do it. Then you get 6 into P1 minus P naught by 4, P1 minus P naught by 4, minus and into minus plus 8 into, 8 also got cancelled, right? Plus directly 2P, P naught minus 2P1, P naught minus 2P1 equal to what? Final entire thing equal to 0. Then this is, you see, 2 3s are 2 2s are. You get 3 into P1 minus P naught, correct, by 2 plus P naught minus 2P1 equal to 0. Let's simplify it. 3P1 minus 3P naught plus 2P naught minus 4P1 equal to 0. Then if you simplify it, you see 3P1 minus 4P1 minus P1 minus 3P naught plus 2P naught is minus P naught equal to 0. Then you will get P naught equal to minus P1. This is equation number 1. Similarly, by substituting n equal to 1, you get one more equation with P naught and P1. We'll see that. So let's substitute n equal to 1. Then what happens? It will become, so n into 1, P1 into 1, P1 plus P naught, correct, into n is 1, 1 into 4 power 1, 4 equal to 6 into, if you see here, n minus 1 is 0. Here this is, see, this entire thing is multiplied with n minus 1, where n is 1, 1 minus 1, 0, 0, right? So this entire part will become 0. Directly you get minus 8 into, so P1 into n minus 2 is minus 1 plus P naught into whole brace into n minus 2, which is minus 1, into 4 power 1 minus 2 minus 1 plus n into 4 power n, correct, plus what is n? 1, 1 into 4 power 1, 4. So if you simplify it, you get P1 plus P naught into 4 equal to, let's do it here, minus 8 into, is it not P naught minus P1? Yes, P naught minus P1 into minus 1. P naught minus P1 into minus 1 is P1 minus P naught into 4 power minus 1. 4 power minus 1 is by 4, correct? Yes, so this entire thing by 4 plus 4. So if you simplify it, then what happens? So here what I can do is, this area I will simplify first. So minus, I can cancel like this, 4 1s are 4 2s are. Then you get minus 2 into P1 minus P naught plus 4. Okay. Now, so this would become P1 minus P naught into minus 1 is P naught minus P1. Minus 2 into P1 is directly minus 2 P1. And minus 2 into minus plus 2 P naught plus 4. That would be equal to 4 P1 plus 4 P naught. Right? See here. 4 P1 plus 4 P naught equal to this one. So if you simplify it, 4 P1, and if I send minus 2 P1 that side, it will become 6 P1 equal to, if 4 P naught comes this side, it would be minus 2 P naught plus 4. So you got one more equation, which is nothing but 6 P1 equal to minus 2 P naught plus 4. If I cancel it with 2, 2 3s are 6, 2 1s are 2, 2 2s are 4. Then it would become 3 P1 equal to minus P naught plus 2. This is equation number 2. So what I do is, P naught is nothing but minus P1. Let me substitute. It would become 3 P1 equal to minus P naught. P1 is minus P naught is what? Directly P1, correct? So P1 plus 2. So 2 P1 equal to 2. Then P1 would become 1. And we know the relation between P naught and P1. P naught is just opposite to P1. So P naught will become minus 1. So finally we got P naught value, P1 value, which is 1 and minus 1. So substitute them back. You get particular solution. Finally, particular solution is what? P1n P1 is what? 1. 1 into n plus P naught minus 1 n minus 1 into what? N into 4 power n, that's it. So n into n minus 1 into 4 power n is the particular solution. But what is homogeneous solution? So we know that homogeneous solution already for that, because characteristic equation for that solution is r square minus 6r plus 8 equal to 0. Then you get roots r minus 4 into r minus 2. This part is already done. You get roots 4 comma 2. Then for this for this problem, homogeneous solution is, alpha 10 into 4 power n plus alpha 20 into 2 power n. Already we did it in previous problem. Take that. So final answer I am writing here for this problem. Final answer is, that means solution to recurrence relation is, always remember, particular solution plus homogeneous solution. What is homogeneous solution? Here this one. Okay. So that is nothing but, what is particular solution? N minus 1 into n into 4 power n plus homogeneous solution is alpha 10 into 4 power n plus alpha 20 into 2 power n. This is the final answer. Sir, again we have a doubt. What is that? How to compute alpha 10, alpha 20? Simple. Take n value. So we know that this is an, correct? Final answer an equal to this one. Take n equal to 0. Okay, then what happens? You get a naught equal to something. Then we know that a naught is what? 8. Now next. So next time you equate this one to a1. a1 is 22. First of all, substitute n value 0. After that n value 1. You know the values. There are only two variables, alpha 10, alpha 20. Then we can get alpha 10 value, alpha 20 value. Correct? So but it is very lengthy one. We know that. So do you think this kind of question they ask in GATE? They don't ask. So and this is a procedure, if you follow you get it, but in GATE generally they don't ask this much lengthy question because they take at least 10 minutes of time. So at least one more thing what we can do is, so generally don't try to find out alpha 10 value, alpha 20 value, just keep this as it is, so that at least we can save the time, correct? And we can understand the time complexity by seeing this one. So this recurrence relations time complexity, n minus 1 into n into 4 power n plus some constant into 4 power n plus some constant into 2 power n. In that way we can understand. But don't try to compute this value and this value. It takes lot of time. But you know the procedure. For completeness, let me do it. So how to find out alpha 10, alpha 20? I will show you now. Let's find out alpha 10, alpha 20. So let's substitute n value 0. Since it is a complete solution, now we can substitute n value 0. Whenever I substitute n value 0, a naught will become what? We know that whenever n is 0, a naught is 8. That's why directly I can write here 8. So I am substituting n equal to 0. Then a naught, which is nothing but 8, equal to, right, 0 minus 1. This entire thing is 0. Directly you get happily alpha 10 into 4 power 0 plus alpha 20 into 2 power 0. Then this will be alpha 10 plus alpha 20, which is nothing but 8. Equation number 1. Now substitute n value 1. What is a1? 22. 22 equal to n minus 1. This would become again 0 because n is 1, right? 0. Directly you get alpha 10 into 4 power n plus alpha 20 into 2 power n. N is here 1. It would be 4. It would be 2. Correct? So you get 22 equal to 4 alpha 10 plus 2 alpha 20. If I simplify it, it would be 2 2s are 4, 2 11s are 22, 2 1s are 2. So here alpha 10 plus, 2 alpha 10 plus alpha 20 equal to 11. And alpha 10 plus alpha 20 equal to 8. Let me do subtraction so that I can eliminate this variable. It will be alpha 10 equal to 11 minus 8, which is 3. Since alpha 10 plus alpha 20 is 8, then alpha 20 should be 5, right? We got alpha 10, alpha 20. In that way we have to find out alpha 10, alpha 20. So final answer is, for your recurrence relation, final solution is particular solution. We know the particular solution already. You write it a power p, right? An power p plus an power h. Sir, what is the meaning of an power p? This is nothing but just a symbolic representation of particular solution. I want to say that my recurrence relation is an, and this set form of an says that all the solutions for an, Okay, and this P represents particular solutions. Okay, so finally this recurrence relation solution equal to particular solution of the recurrence relation plus homogeneous solution of recurrence relation. So particular solution is n minus 1 into n into 4 power n, correct, plus homogeneous solution, just now we got alpha 1 0 which is 3 into, so 4 power n, plus alpha 2 0. What is alpha 2 0 value? So alpha 2 0 value is 5. 5 here, 5 into the second root is what? 2, right? 2 power n. This is the final solution. Understand? Now let me summarize how to find out the final solutions. Whenever you have non-homogeneous recurrence relation, first of all find out the particular solution. Okay, so you will get some particular solution, whatever, and that there will be variables like p0, p1, p2, whatever. Then what you have to do is substitute that particular solution into original recurrence relation directly here. Okay, once you substitute, then if that particular solution has two variables, then what you do is substitute n value 0 and n value 1 into the equations, then you get two equations and simplify them and solve them, you get values of two variables. Sir, what if I have three unknown variables in my particular solution? Then again substitute this your that particular solution into recurrence relation first. After that, substitute n equal to 0, you get an equation. Substitute n equal to 1, you get an equation. Substitute n equal to 2, you get an equation. Solve that 3. In that way, finally you find out the particular solution. Once you find out the particular solution, then you go to homogeneous solution. How to find out homogeneous solution? So if you have linear homogeneous equation, like, so what you remove is f of n, then you get homogeneous part. In that homogeneous part, you find out, homogeneous solution. You know how to find out the homogeneous solution for homogeneous part. Example, in this one, remove this one. For this problem, you find out the homogeneous solution. Then you get something like alpha 1 0 into something plus alpha 2 0 plus something, so on. Then again you get variables, correct? So whatever you get, let's leave them first. Then write this complete solution. What is your complete solution? Your complete solution will be particular solution plus homogeneous solution. So example, your solution will be like this: n into n, example in this problem, n into n minus 1 into 4 power n plus this homogeneous solution, you write it, whatever you get. So don't simplify alpha 1 0, alpha 2 0 initially. So you write like this, a n equal to this one. Once you get it, now substitute n value 0, n value 1 into this equation. Then what happens? It will be a naught equal to something, a1 equal to something. Example, if you have two variables like alpha 1 0, alpha 2 0, then substitute a naught value, a1 value. So we know a naught value and a1 value. That means equate this equation to, n equal to 0, equate this equation to a1. So since a naught is known, a1 is known, then what happens? These two equations will become equations with only this alpha 1 0, alpha 2 0. Then we can simplify like as we did in the previous problem. If you have three variables, then what happens is, definitely when there are three variables, there will be three values like this, a naught, a1, a2. Don't worry, it will be like 36 or something. Then three times you substitute and we can get the values. So this is all about solving the non-homogeneous linear recurrence relations. So remaining things, so far we have seen how to simplify linear homogeneous solutions, how to simplify linear non-homogeneous recurrence relations, correct? That's it. For linear homogeneous solutions, you did simply, you find out the homogeneous solution directly. For linear non-homogeneous equations, what you did is, you found particular solutions and you found homogeneous solutions, you added them. That is the formula. Okay. For remaining things, if you have non-linear recurrence relations, so we are not going to do anything. So in the GATE exam, they don't ask that, because there is no particular procedure for it. That's why don't bother about non-linear recurrence relations. Second one, sir, linear recurrence relations with variable coefficients, still not required, because they don't have procedures. Okay. Similarly, linear non-homogeneous recurrence relations with variable coefficients, still don't worry. You only worry about this one, is linear homogeneous with constant coefficients, linear non-homogeneous with constant coefficients. Only for this we have formulas and we did it. Okay. So generally in GATE exam perspective, no one will ask you these questions. That's why so far there is no question. For completeness I am teaching. Otherwise, happily you can skip this part if you want, if you don't understand. But try to, go through these videos once and solve 2-3 problems. That's it. It takes only half day. Okay.